our phone doesn't work. And we don't have internet.
All right, we are indeed recording for the people who can't be here right now. So remember that we're recording. All right. For those of you who are coming to Commerce either today or on Tuesdays, they do have the little Fenty or whatever sign out now with the QR code outside of our classroom. So my understanding is that that will be the way that they kind of track in case somebody in this classroom were to be reported positive for COVID, that they would let everybody know, oh, you may have been exposed, be careful, go get tested. So if you will, whenever you come into the class, scan that, and it'll supposedly, even if you don't log out, you can scan in and scan out, I guess. So even if you don't log out, it'll log you out at the end of the day, or when you go to another location, it'll log you out of here. So just be aware of that, and that is not how I'm calling roll. So I don't know if we're going to get records of those attendances or not. So I think it's really more for the COVID situation. So for us, I will continue to call roll because that way I know I have a record. Just FYI. All right, so let's see. When we last saw our group, here's another one. Hi, Samantha. When we saw you guys, we were starting to work on parallel lines and their properties. I think that was the last thing that came out. So I have not yet made you guys a package, I'm sorry. It's been a little bit of a busy week. We'll get you a package. Instead of having everybody touch everything, I'm just going to hand out and then you can keep. Okay. So normally I pass it around and all that. What I'm doing, if you can't see me, is I am giving everybody a safety compass and a protractor, and those will be yours for the semester. So if you're not here today, but you're here on Tuesday, you'll get your stuff on Tuesday. Sorry, I just didn't have it together. I still don't have it together. I certainly didn't have it together for Tuesday's class. So I'll get you a stack of stuff, and it can just be your stuff. If you, like Samantha, I know you're in Navarro, if you need a protractor and a compass, just like email me, and I'll send you a package in the mail. Sometimes that gets crazy in the mail, but I'll get it out to you if you happen to not be ever on campus. So, let's see. If you're here on Tuesday, just grab a seat. If you weren't, then grab one of each of the handouts in the back. Rest of the semester. Hang on, people. You just do it all day. All right, so for those of you who are not in the classroom, this is what we've got. We've got a compass and a protractor. And then we also have a stack of what's called patty paper, which literally it's called patty paper because it comes from between your hamburger patties. Have you seen that kind of paper before? Yes, okay, so it's that kind of paper. It's really super thin. It's not quite wax paper, but it's similar to that, like a parchment paper kind of thing. So what I was saying was when we left class the other day, we were talking about parallel lines and their properties. Oh, you know what? Before I go forward, we should have the new student introduce himself, because I don't think you introduced yourself. You didn't on Tuesday, right? You weren't doing. So what do we do? This is your I'm gonna pick on you. I'm sorry. This is your participation grade from Tuesday. Was to do an introduction. It was name, major, hobby, and a fun fact.
Oh, Elijah Prince. My major is physics. I like to work with lasers, build them too.
Ooh, cool.
Fun fact. You need a nonlinear crystal to produce a green laser.
Fun fact about you. I'm sorry, we weren't clear enough. What's something interesting about you or different that you do that not everybody does? Or something cool?
I'm sorry, I'm not special.
On the spot, right? I'm not special. Yeah, he still gave us a fun fact. All right, it's nice to meet you. So,
Nice to meet you.
yay. Gotcha. All right. So we were talking about parallel lines. So I want to real quickly back up for just a minute. There are about 3 definitions I feel like we need for the homework you're going to have to do. And I don't necessarily think that those were given. I don't really feel like they were given on even in the glossary necessarily. So, all right. So one of them is a plane. Have y'all defined a plane? Was that in the glossary? I don't think it was. So let's define planes. P-L-A-N-E. What do y'all think? Have you heard of a plane before in geometry?
Yeah.
Okay, so what does it represent? Like 1-dimensional, 2-dimensional, 3-dimensional? It's
Something described by at least 2 dimensions, confined by a particular set of vectors.
ooh, he's got some physics talk for me. So yes, exactly. So I can have a plane. A plane is a 2-dimensional object, okay? It has length and width normally is the way we think about them. So I could define this or whiteboard as a plane. You can usually think a piece of paper, okay? Because it's got length and width, but it doesn't have any depth, okay? And so going in different directions, he said different vectors. So this plane right here would be different than the plane of the wall that is behind it. They're both going in the same direction. So for purposes of the algebraic stuff that we've talked about, they would have basically the same slope to them, okay? Meaning that they would be parallel to each other, we hope. We hope that that's the same thickness between them here and there. But I could easily have a plane that's going like this, that cuts right into it, right? And it would have a length and a width to it. So the ceiling is its own plane if I just think about the surface of it, right? So it's just going straight there. And it intersects with that plane, right? How does the ceiling intersect with the wall? How many places? One spot, just this point right here?
Well, it's that entire line.
Oh, all of these points, all the way that direction, those are intersection points, right? So it intersects, a plane intersects another plane in a line. Okay, they overlap there in that line. And we would assume normally this plane goes on forever, that direction and that direction. But for our purposes, we only see what's in this room, of course, and this plane would go on forever up and down, okay? So normally people just kind of think a sheet of paper. So this plane right here, this sheet of paper represents a plane, okay? So it has length and width. Two-dimensional, like a sheet of paper. But no depth. Okay. And it's also important what he said about it's going in a particular, it lies in a particular way, right? Okay, so if I have a plane, this plane is, and again, maybe think GPS coordinates. If I have this plane right here, then this plane that's below it, another sheet of paper, those are different planes, right? Because they're on different levels, different heights, so to speak, okay? So normally we have to give them kind of a direction, okay? And there's a lot more mathy conversation you could have with that, a lot more mathy definitions. But that's the kind of thought that we would normally have for a middle school student that we were trying to teach is, okay, so here's what I'm looking at, all right? And then the other thing, there are two more words that I want to describe, and then you should be able to do the homework that I handed out. One is collinear. Hey there.
Good afternoon.
I thought for a minute you got stuff from the library. I was jealous. Okay, collinear. So linear, we already know that's a line, right? Okay, so things that are in a line, we can have multiple points on that line. So what do you think it means to be collinear? Together, okay? So if we're talking about points that are collinear, they're together on the same line, right? Okay, so that's exactly what we mean. So normally it would be points on the same line, but it doesn't have to be. It could be segments, rays, etc. Those could all be collinear. They could be all rays that are on the same line, all segments, and so on and so forth. So it's just things that are on the same line, okay, together. Okay, so that means that this point here and this point here that are on that line where these two planes intersect, those are collinear. They're also coplanar. So, I mean, yes, nods, of course they are. Why?
They're on the same plane.
Okay, so that if they're on the same line, that line is on the same plane. That means the points are on the same plane with that line, right? Okay, so that was an easy sell. Okay, so that's the third word, coplanar. Things that are on the same plane. So one way to find these things out, if they are collinear, coplanar, those kinds of things, collinear in particular, is to look at the slope. Okay, so if we know the slope of one of the planes and things aren't at that same slope, then they must not be on the same plane. Okay, and of course that's the way it works with lines. We already know if you have 3 points and they're supposed to be on the same line, then the slope between two of them has to be the same as the slope between the other two, right? Or the outside two, any way you want to think about it. All right, so those words I noticed, I wanted to throw those in there real fast before we go on with our look at parallel lines. Those words are in your homeworks, the 1.1 building block that I sent out, gave out on Tuesday. So I saw them in there and I went, oh, we got to get that in there. So for instance, number 12, sketch 6 points, A, B, C, D, E, and F. No 3 of which are collinear. Name the lines defined by these points. How many lines are there? Let's talk about that one. So I need 6 points and no 3 of them can be on the same line. Okay. So how in the world are we going to do that, guys? What do y'all think? Y'all want to play with it for a second? It's straight off your homework, so this will help you this weekend as you're studying, working on your own. Okay, so I see Ryan sent us a chat that says, will it make 3 lines? Maybe. That is definitely a possibility. He's probably, why would he be thinking 3 lines?
Points of each line.
Yeah, he's thinking 2 points on each of those lines, right? So he's thinking, oh, okay, if none of them can be in the same, if there can't be more than 2 in any one line, then maybe I need 3 different lines. I see what you're thinking there, Ryan. I like it.
So there can be multiple answers.
Oh, sure. Let's see what we come up with. Okay, so let me give this a whack. We'll see how well. My artistic abilities are never good, guys, so please forgive me as I draw things. And this whole class is drawing things. So it always ends up, my triangle has a curvy side or something crazy. So I'm going to say, here's A and here's B. Okay, so for sure those 2 are on a line. Okay, I can connect them like this. Which means that I can't put anything else straight out here, this direction, all right? Okay, oh, I heard Samantha's got a guess of 10 lines. Okay, we'll see, Samantha. I'm gonna continue with the concept that Ryan gave me because I like it. It's a really great idea. Let me make another line with 2 other points on it. Now I need to kind of be careful about it because, for instance, I could put the 3rd point C here, and that would be fine. If I do that, though, that it will be in a line with A. You see that? So I have to kind of watch out for that. So if I put C here, I don't have to put it directly underneath A, but even over here, there's C. Then whenever I go to put D in there, I got to be a little bit careful about him because why? So like, I want him in a line with C. That's what we said we were going to do, right? I can put him here or here or here or here. You care? Okay.
As long as it's not directly under B.
You don't want it directly under B. Okay, so I'll put it way out here. Is that okay? All right. So now I've got C and D. Remember we talked about last time all of our points are capital letters, so be careful that you're doing that. Okay. So those are the 2 lines that I meant to create, right? The AB and CD. If they're lines, I should put arrows on them. I should be correct in my notation. But even though those might be the lines I meant to create, I also created some other lines, right? Because it said no more than 2 can be on any line. So what other lines did I create, even though I didn't mean to? Yeah, because it only takes 2 points to find a line, right? To find a line. So here I go. I've got A to C. Here's a line. And I've got B to C. Does everybody agree? Okay. And I've got D to B, I heard. And I've got A to D. Which is fine. There's still no more than 2 points on any of those lines, right? Get them all? I think we got them all. All right. But now's the really tricky part, right? Because now I need to create that 3rd line that Ryan wanted me to make. That guy's going to have E and F on it. So all I really need to be careful about is, like, you see right here where these 2, for instance, this line comes through here. I don't want one of my points anywhere in here, and I certainly don't want it in that intersection, right? Because that would put the 3rd point on both of those lines. So as I create this 3rd line down here somewhere else, and by the way, there's other ways to do this, right? This is just one, you picked it. So I need a line down here. I need E and F on it. I'll go ahead and I'll draw the line. That's my 3rd line. I like that idea. Make 3 lines. But then I have to pick E and F carefully, right? I for sure didn't want C underneath A and then E underneath C, right? That would give me a boom, boom, boom right in a row. I don't want those. Okay, where y'all want to put these?
You can put them under A and under B.
I actually could put one of them under A and B, right? Like I could make a square kind of thing, whatever.
A
So,
hexagon.
hmm?
A hexagon.
Yeah, so I heard I could put E here. That would be okay because it would just be those two on that line, right? Or I could continue to build outward and make more of a trapezoid. Okay, I'm hearing more of a hexagon. I could pull it in and make more of a hexagon. So however you want to do it, it doesn't matter. We could make different pictures or whatever, as long as there aren't three of them in a row, right? So I accidentally made this line, accidentally on purpose. And I accidentally on purpose made, where was it here? Under B, she said, that line. All right, so for sure those. But I also have other lines that I have made, right? So even though we only set out to create 3, let me go ahead and make sure and help me if I forget one. So I got the C to E, but I also have C to F. Okay, so we're good there. I have the D to F, but I also have D to E. Okay. I have A to C, but I need A to E and A to F. All right. A to E, A to F. Okay. And I have B to D, but I need B to E and B to F. Okay. Did I get all my connectors or am I missing some? A is going to all 4 of those. B is going to all 4 of those. I think I've got all the connectors. Does anybody see one I missed? Okay. All right, so how many lines are there? Bunch. Okay, now the more complicated, the more I try to keep things from lining up, the more I may have weird shapes, right? But let's see, there's 1, 2, 3, 4, 5 arrows coming off of this point, and 5 arrows coming off of this point. Okay, 5 arrows coming off this point, 5 arrows coming off this point, 5. So 5, 10, 15, 20, 25, 30, but that's 2 ends on each line. So how many lines do we have? 15, I think. Okay. So Samantha was close. That was a good guess. So we have 15 in that drawing. There's probably other ways to draw that thing out. I think you would still have the same connectors though, if they're not more than 2 of them collinear. All right. Isn't that a fun homework question?
So fun.
Oh my gosh. Aren't you glad we did it as a group? So there's other stuff on here. Number 14 talks about coplanar. So, and they've got a lovely picture for you. I also noticed on the back, so everybody's okay with the front? Again, that's a lot of definitions that hopefully you've picked up over the years. The back is also still definitions, but notice that it has to do with, it's called pool room math, so it's a bunch of angles like you would do when you're doing pool. So like the first one, A is the blank of angle BAE. What's that called? The turning point?
Vertex.
The vertex, right? Okay. So there may be a need to look up some of these vocabulary words. I think most of them would be in that glossary, but if not, then you can just Google again. AD is a blank of BAE. BAE. AD. What do y'all think? What's AD doing to BAE? It's bisecting it, right? Okay, so it's a bisector. Does that make sense? T-O-R. So those kinds of vocabulary things, that's not so bad. But at some point down here, exercises 6 through 10, use your protractor to find the measure of each angle. So angle PRO, this big obtuse angle here, angle pro. So that's why I just gave you protractors, right? So take those home. What we've got, for those of you who are not necessarily, ooh, Samantha had bisector also, I like it. Yeah, this vocabulary. We've got these little orange ones, and these are considered safety protractors. The safety bit of these comes out, guys, because this is a plastic that's fairly flexible. Okay, so if one of the students in the class hits another student with it, hits another student with this, they're unlikely to poke their eye out, kind of thing. So that's why it's considered safety, especially the compass. We'll show you how to use this in a bit, but the compass, remember, do y'all remember when you were kids what your compass looked like? Did you have a compass? What was it? Yeah.
Was it the one where you stuck the pencil in it and you just...
Yes, so the one, I wish I had thought to bring it. The one that I use, oh, she's got one, yay. I'm just touching your stuff. Okay, thank you, ma'am. Yeah, the one that I used was pretty much like this, except for it wasn't plastic at all. Mine was all metal, so this edge here was a metal thing, and it's got a pointy at the bottom, so you stick that in, that's the center of your circle, and then it's got a pencil attached to it, so you make your arc that way, right? That's the old-fashioned protractors or compass. So these don't have that little pointy stick metal thing, so thank you. So they can't stick them into each other and hurt each other. So that's why they're considered a safety thing. And I'll show you those a little bit later. But anyway, here we go. And the other thing that I like about these orange ones, so everybody will get one, even people who come on Tuesday, or if you're not here, like I said, just let me know. I'll get you a packet. You can see through it. See, it's called a view through safety plastic. So that means that as I line this up, help me out, guys. How do I measure an angle? You just stick your protractor on there and measure it.
Yeah, put it in the middle,
It's 120.
on the 180 line.
Okay.
And I'll put it in the middle of that.
All right. So I'm hearing, here's this flat line across the bottom. That's your point of reference, basically. And you want that to line up with the flat line at the bottom of the angle, right? Okay. So I heard I want to line those two up. And then what?
I normally put like the middle right on there for the exact angle that I'm looking at. The 90 degree more part of the exact angle I'm looking at.
Okay, good. So do you see how this makes a 90 degree in here? That's what Demondre just said. Okay. So that bisector here that's dropping down, that's like the center of your protractor. In the old days, we had like a little hole there maybe, and so maybe you put your pencil on it and then adjust the tilt of the protractor. So the idea here is that that T, so to speak, will be right on the vertex. In this case, we're doing an angle PRO, pro. So I want to put that right on the R, right? So the bottom should be lined up and the little 90 degree mark should be lined up with where your vertex is. And if I do that correctly, it's hard to see through these things, then I measure it. And by the way, a lot of protractors do this. They'll have 0 to 180 on one side and then 0 to 180 going the other direction on the other, right? So mine has the 0 here. If yours doesn't, then you'll want to flip it so that the 0 is on your flat, right? On your horizontal. So 0, and I follow it all the way around, and this guy looks like he's somewhere between 130 and 140. So it's not exact on mine. This part of the angle, that side of the angle isn't long enough for me to get it where I need it to read it exactly. What can I do about that? Yeah, extend that side. Does that make sense? So if you can't read it, I want you to be as accurate as possible, right? You can just come along here and say, oh, I'm going to extend that line, make sure that it's got the right slope with it, whenever that it matches the slope of the actual side, and then try again. And what's it look like to you guys? Mine looks like 137.5, 138, somewhere in there. Okay. 137, 138. That's what I would say. And for my purposes, you don't have to be exactly right on. When I want exact, we'll be using the software. Okay, because the software can be much more exact than we are. We have a lot of human error because we're human. Okay, so if you're within a couple of degrees of what my answer is, I'm happy with that. What I wouldn't want, so I said like 138. What I wouldn't want is for you to say, oh, I think it's 140, because it's clearly not getting all the way over to 140, right? So if you fudge it that much, we're maybe -1 or -2. But if you're like 137, 138, 139, I'm okay with that. That sounds about right to me. Anybody get another measurement? Okay. So probably you've measured angles when you were younger and you know how to do that, but now we all have a very go-to. If you're like, this isn't quite lining up, go back and watch the video. It'll be online, and hopefully it lines up well for you and you can do that. So there's some measuring angle things in there. Draw these things on your protractor. It's a similar process. If you need it to be a measurement, you can start with your baseline of the angle, draw that out, use the straight edge of your protractor to make a straight line, and then put the 180 mark on it. And then you can go back and say, okay, how am I gonna make this 90 degrees? Put a point there, connect the dots, all that kind of stuff. So for sure, y'all should be able to do those things, I think. Talks about hands of a clock. You can do that. Okay. Questions about this homework now? I know we haven't done tons of stuff yet in the class, so y'all are like, what? We have homework? Yes. So, but we've got the vocabulary. It's really a vocabulary homework. And then now you know how to measure, hopefully.
On the clock, question number 14, 15, and 16, I guess each time of those forms 2 angles.
Oh, very nice. So which angle do you think they want? Yeah, so normally whenever we're measuring angles, this is a really good point. Let me put it on another sheet of paper so I can actually draw one for you. So like she's saying 3 o'clock. Do you care which one? Okay. So this is number 14. 14 says, consider a clock. I'm going to draw my Webster clock. Ooh, oh, that's not I was about to say, it's not a bad circle, then it went bad. So, sorry. All right. Okay, so on 3 o'clock, at 3 o'clock, the hour hand would be here and the long minute hand would be there. Everybody agree? And it says, tell me how big the angle is that's formed by those hands. Okay, so she wants to know which angle, which is a great question. Okay, there's one small angle here, which is less than 180 degrees, but there's also this larger angle out here. That's your question, right? Okay, make sure I interpreted correctly. Okay, there's that larger angle out there. Together they make an entire circle, which we know is how many degrees all the way around? 360 degrees all the way around. So which one do they want? They want the smaller angle because they want the angle that is less than 180 degrees. Okay, otherwise it's considered like an exterior angle. Okay, so that's 180 degrees. Anytime they tell you measure an angle, they assume, and it's probably a bad assumption, but they assume that you're going for the one that's less than 180 degrees. Yep. So the other one would be 270. And like if we're doing trig and stuff like that, we will certainly use 270 degrees, but that's not the one that we care about so much in geometry. So in this case, the angle answer is, that's 90 degrees, right? Or I can measure it if I need to. Okay. Great. All right, so we feel comfortable with the homework. I don't see any questions. So, all right, cool beans. Here you go. Work on that. It's going to be due next Thursday. So 1 week from today, that means that you can come see me during my office hours next week and ask me questions. If you run into something, you're like, oh my gosh, that'll be fine. I don't normally answer tons of homework questions in class because we can get bogged down on that. And if some people have already done it and they're like, oh, I already did this, then they get bored and that kind of thing. But if there's like a real quick question answer kind of thing, I don't mind doing it. But other than that, come see me on the office hours or, you know, work on them on your own. That'll be great. All right.
The next Thursday, right? Not Tuesday.
Thursday, yes. So anytime I give homework, except for really close to test day, that's the only day it might get crunched, I try to give a week. That way, if your study day is Wednesday and you do all your homework every week on Wednesdays, then we'll hit a Wednesday during that week at some point. So try not to crunch anybody's study time. 1 week. Now, if you finish it on Tuesday and you're a Tuesday person, and you're like, I'm gonna just go ahead and scan it and load it into D2L and be done with it, then I'll have a spot in D2L that you can upload it and it'll be done. So Thursday by midnight, 11:59 p.m. There we go. All right, moving on. Let's talk about what we were working on the other day, which was relationships for parallel lines. So there is one thing, a cheat that I like to do, and I forgot to, I'll go grab one in a second maybe. But if you need to do parallel lines, if you are as terrible of an artist as I am, you can cheat a little bit. So you can try to draw as straight of a parallel line as you can draw. Sometimes I'll do them sideways or up and down or whatever. Hey, that's not bad. Okay, you can try to draw as straight as you can, but a cheat that I use sometimes is I will get a ruler. Ruler. And I will do the outside edges, both edges of the ruler. Those should be parallel to each other. Then it's not about how bad of an artist I am. So there's you a cheat right there. So you need a set of parallel lines. It's fast. It's easy. If you have a smaller ruler than that, it'll be skinnier, so they'll be closer together, so they're not wasting as much of your paper. So we've got that kind of thing going on. All right, so I'm going to call both of those parallel. These are parallel to those. This one's parallel to that one. Now notice that on one set I put one chevron, and on the other set I put two chevrons. Okay, why? Yeah, in this case it's the parallel mark, right? Not quite congruency, but it's the same idea as the congruencies, right? So these two are parallel to each other, but they're not parallel to this one, so they don't need to have the same marking. Okay, so these two have two, that one has one. All right, so we had drawn, what was the brownie points? What was that word?
Transversal.
Transversal, yeah. We drew that on Tuesday. Okay, and we had angles 1, 2, 3, 4, 5, 6, 7, 8. And whenever we were working on those, we had just gotten one vocabulary word basically, right? What kind of angles were they? Vertical. Okay, vertical angles. Gabriel had given us that one. Okay. So for vertical angles, we have angles that are across from each other when two lines intersect. So notice that it's actually when two lines intersect, or segments, it could be segments, it doesn't have to be lines. But it's when two lines intersect, it's not what's going on here with parallel lines. So technically, we don't even need parallel lines to study vertical angles, but they come up a lot inside of parallel lines, so that's why they're there. So remind me what an example of vertical angles that were up here. Okay, 1 and 4. Angle 1 and angle 4 are, and I'm totally going to be lazy, VA. Vertical angles.
What does it say? The angles that are crossing each other. I can't see the word.
When two lines intersect, is it the mouse is in the way? There you go. No problem. Stinking cursor. When two lines intersect. So angle 1 and angle 4 are vertical angles. All right, and then we had also said, for instance, 2 and 3 are vertical, but they're not congruent to the other two. So we have this little conjecture. Oh, what's a conjecture? Okay. Junction, and what's your function?
Some come together as one. Come together as one.
Okay. Conjecture. A conjecture is like you have a thought about something and it's kind of congealing in your head. So you have an idea, a hypothesis maybe. That might be a synonym for conjecture. So we think, so our conjecture is we think vertical angles are congruent. And I don't know why, guys, there are a bunch of C words in this class. I have noticed that over the years. It's like there's so many C words in this class. So conjecture, we think vertical angles are congruent. 1 and 4 are vertical angles, and we actually already marked them as congruent, or I did on my paper. Right, I've got the congruency symbol up there. And we talked about that the other day, why that might be. I gave you a basic outline for the proof of it, which sooner or later we'll do proofs in here, and it'll be so much fun. It'll be awesome. But I'm going to, quote, prove it to you today. And my proofs, whenever we use this patty paper, everybody's got some, did you get patty paper? Here you go. My proof, whenever we use patty paper, is, you're welcome, a middle school math student proof. Okay, so what does that mean for us? It means if you're going to teach high school, this won't hold up. Okay, if you're going to teach high school, you're probably going to have to do a 2-column proof to prove something, work it out step by step. But for middle school students who maybe don't have those cognitive skills that we want them to have to be able to prove things, this, I'm telling you now, this will convince them. Okay, so they will be convinced whether you have truly proven it or not. So what we're going to do here is we're just going to draw on our patty paper 2 intersecting lines. And I like to draw them, just a teacher moment. Oh, it's kind of not enough. I like to draw them so that there's a clear and definite acute angle, and there's a clear and definite obtuse angle. If you draw them close to perpendicular, then they look kind of 90 degrees-ish. All of the angles will look 90 degrees-ish, and that's not as easy to prove it to kids. There we go. That's better. Now you can see it. All right, what am I up to? Angle 8 was up there. Let's just jump to 11, 12, 13, and 14. 11, 12, 13, and 14. All right, so I've got 2 lines intersecting. I did use a ruler because if I don't use a ruler, my lines aren't straight, and then whenever I go to do what I'm about to do, it won't be straight, and y'all go, it doesn't look the same to me. Okay, but so here we go. We've got these 2. What are the vertical angles here? Yes, so I have a pair 11 and 14, and I have a pair of vertical angles 12 and 13, okay? So with your kids, if you were in the middle school classroom, you would give them some patty paper, you let them draw this out, And then we're gonna use a lovely paper folding method. So what I wanna do is I wanna fold this up so that 14 is on top of 11, or you could fold it down so that 11 is on top of 14. Now, when I do that, is that gonna work? Why not?
You can do right on the
It's weird.
right.
So she's saying whenever I go to fold it, I can't fold it way down here. I need to be folding right on this point here. Y'all help her out. What the vertex? Yeah, vertices is the plural. So I need to go right through the vertex. So okay, what if I do it like this? That's right on the vertex. I like to be the facetious student in the classroom. That's on the vertex. So what's wrong with it? They're not lined up. Okay, and I like to be the facetious student because you're gonna have somebody that's probably not even trying to be facetious in your classroom who just does these things, oh, I do what you do, and then it's not right. So it needs to be folding through the vertex where the sides of each angle line up on top of the other one. Now the lovely thing about patty paper is even on the overhead, guys, y'all could see what I was doing, right, when I was doing it wrong. And now that I'm doing it right, you can see they line up perfectly on top of each other, right? Okay. So we can convince students, especially if I have a room full of 20 or 30 students and they all do it and it works for all of them and they all drew their angles in different ways, you know, this line was flat and this line was angly or whatever. So if it works for all 20 or 30 of us, it must be true, right? That's the way we think in the middle school level. So that lets me know that. I can also go the other way. So if I wanted to do the other set of vertical angles, what would I do differently? Okay, so I folded 11 onto 14 last time. Now I want to, and that showed me that 11 was the same size as 14. So now I want 12 and 13 to be the same size, right? So how am I going to show that? Okay, so fold either 12 on top of 13 or 13 on top of 12. So instead of folding up and down, I'm going to fold side to side now, right? Okay, so it's these lovely paper folding methods. And again, I can be crazy and do something like that and stuff doesn't line up and what did I do wrong? Blah, blah, blah. So I need to make sure that I'm folding it through the vertex and that the sides of the angle for 12 are lying on top of the sides of the angle for 13. And sure enough, that looks like one big angle, right? Okay. Does that make sense to everybody? So now we've shown them. We haven't technically proven it yet. Okay, we'll prove it later in the semester. You'll get proofs and it'll be good fun when we get there. But yeah, we'll do the high school proof later. But we've shown that for even high school students are convinced now, we just don't have the technical proof for it yet. So we've shown it to them, they can see it, they can play with it, and both pairs were congruent. Is that all right? Okay, so those were vertical angles. And that was something Gabriel gave us the other day, I think. What else do y'all know? So there's other stuff going on in these parallel lines. Yes, ma'am.
Angles 5 and 6 are supplementary.
5 and 6 are supplementary. What does supplementary mean? Okay, when you add them up, they add up to 180 degrees. Does everybody agree?
Yeah.
Okay, so supplementary angles. Angles, let me say, whose sum equals 180 degrees. Okay. Now, I'm going to get a little more specific with her. She is exactly right. Nothing wrong with that. But I'm going to say they're actually even a linear pair. What do you think that means? Pair means two. Okay, so two angles. So I could have more than two angles that add up and gives me 180 degrees, but these are exactly two, and what? What do we think that linear means? Form a line, okay? So two angles who form a line. And what that means is they add up to 180 degrees, which is what she said. Okay. So in your book, though, they might not say supplementary. They might call it a linear pair. So those are sometimes interchangeable. However, supplemental angles don't have to share a vertex. They don't have to make a line. So that's the difference. Supplemental could just be sitting out here beside by themselves. So there you go. Very good. What else you got about here?
Opposite, interior, or congruent.
Oh, do you know what those are called exactly? They're opposite interior. So she's talking about interior means what, guys? Inside of the parallel lines. That's what she means by interior. Okay. So I think sandwiched. It's sandwiched between, I think we had this was L and this was M the other day, and that guy was P. Okay. I'm not on the same notes. All right. So angles that are sandwiched between L and M, between your parallel lines, those are considered interior, and angles that are outside of those are exterior. Okay. So cool beans. So she said opposite. So which ones are those? Give me an example. Okay. I heard both of them. So I'm going to go with 4 and 5. She says those are congruent. 4 is congruent to 5. You know what those are called? Do you remember the mathy word for that? They call them alternate interior angles. But I think of it just exactly the way you do. So, alternate interior angles. So what's the alternate or the opposite part of 4 and 5? Good. So if you think about the line P that's going through here, angle 4 is on the right-hand side and angle 5 is on the left-hand side. So that's what they mean by opposite sides or alternating sides of the transversal. Okay, so alternate interior angles. Oops. 2 angles that are with inside the parallel lines but on opposite sides. Of the transversal. Absolutely. And she has a conjecture. She has a thought. She has an idea. Hypothesis. Alternate interior angles. Oops. Can't spell today. Are congruent. Alternate interior angles are congruent. That's her conjecture. So, for instance, we said angle 4 is congruent to angle 5. All right, so real quickly, let me harp on this for just a second. Whenever I'm writing this as a sentence like this, the angle is congruent to the angle. We use this notation. Is congruent to. That's how we say that. So it's that lovely symbol. Okay. angle 4 is congruent to angle 5. And that can happen a lot of times, different things. We can say line segment AB is congruent to line segment CD, so it doesn't have to be just angles. The weirdness here is that we are talking about the entire angle, and what exactly, we haven't really defined a congruent yet, so what do we mean by congruent? Okay, it has the same angle measurement, okay? So they have the same measurement. So whenever I'm talking about the angles and I say they're congruent, we say they have the same angle measurement. But when I'm talking about the measurement, like if that was angle 4 and I want to say it's 30 degrees, when I'm talking about the measurement, I use equal. Okay, like on the homework the other day, we had that NQ or whatever it was, and it said equals. That's when they want a measurement, okay? So if it's an equal sign or if they're talking about a measurement, they'll use the equal sign. But if they're just talking about the angles in general, they'll say congruent. It's kind of weird. So if you get those mixed up, I'm probably not going to trash you on a test, but I'd probably put the little tilde thing on top of your equal sign to tell you, oh, it's congruent, not equal, okay? I know, it's crazy. All right, what can we do to show this one? 4 is congruent to 5. Where's my patty paper? Again, these are just middle school proofs right now. This is just what we would do to convince students. Not necessarily a proof. Here we go. Here's my parallel lines. Here's my transversal. Okay, I'm going to call them the same order that we had the other one in. 1, 2, 3, 4, 5, 6, 7, 8 for the angles. Guys, it is so much easier to label your angles 1, 2, 3, 4, 5, 6, 7, 8 than to go, oh, this is angle ABC, ABD. You know, so just if you can do that, make your life easier. Okay. And in this case, we're talking about angle 4 and angle 5, and we think they're congruent. Where did my time go? Where's all my time? Yeah, that's some fun up in here. All right. So I'm looking at this, and I'm like, can I fold it weird? Can I do something to it? How can I line 4 and 5 up to prove it to them? Now, when I look at this, by the way, I see 2 and 3 are the acute angles, and 1 and 4 are the obtuse angles, right? And 5 and 8 are obtuse. So if these all have same measurements, then yeah, 4 and 5 are both the obtuse guys here, right? So they should line up. But I'm not having a good feel for folding here. Folding isn't my friend. So Ashley, right? Ashley says, can we cut it? We can. So let's rip this, or if you have scissors, right between the parallel lines. Cut it right between the yeah. Right between the parallel lines. Does that help me out any? Okay, now I can stack them on top of each other. Does that put 4 and 5? That doesn't quite make 4 and 5 lining up for me. So what should I do? She just doesn't want to be heard on the recording. That's what I mean. Yes, I need to rotate it, right? So that's what I'm seeing the hand motion for. Rotate it around. And then again, this doesn't do it, right? You need to line up your vertices. That doesn't do it. You need to line up the angles, the legs of the angles. But look at that. If I manage to get my vertex on top of each other and the legs lined up nicely, look at that. Those obtuse guys look like they're right on top of each other, and those acute guys look like they're right on top of each other. So that gives me 4 and 5 for sure. That makes sense. All right, does it give me, what's the other two? 3 and 6? It didn't if I had 4 and 5 lined up, right? Oh, no, it could, nope. 7 and 2, 1 and 8, and it does give me 3 and 6, right? Okay, so it gives me both alternate interior there, which is nice. Okay, now hang on a second. So we just proved alternate interior. Is that really good? Okay, but somebody said, I just heard, Demondre said, 2 and 7. But we didn't say anything about 2 and 7. They are, so we know they're congruent, right? 2 and 7, and also 1 and 8. Those are that's the other pair that we have there. So let me pull this back in here. 2 and 7. Well, 2's up here, and 7's down there. Those are congruent. Oh, there we go. So look at them for just a second. Think about it. Here's the transversal. Think about the pin. It is the transversal. 2 is on the right-hand side. 7's on the left-hand side. So it's definite alternate. Everybody agree? Okay. And then I heard exterior, meaning on the outside of the parallel lines. Okay. So we actually just proved this one backwards. FYI, we saw they were congruent, and now we're saying, oh, they're alternate interior or alternate exterior, so they must be congruent. So we're kind of working it backwards, but that's okay. That's awesome. I like it when that happens. So we have a conjecture, don't we? Well, let's define alternate exterior. I have a thing from Samantha says, aren't angles 2 and 6 corresponding angles? Oh, they are. Hold that thought. That's my next definition, just for you. You are absolutely correct. So, alternate exterior angles. I love it when we see these great things. Okay, so these are angles that are outside of the parallel lines. And they're what? Oh, that's our conjecture. But what? They're outside the parallel lines and they're on opposite sides of the transversal. Good. Okay. So we've got those. Here we have, for instance, angle 2 and angle 7. And what's the other set that's alternate exterior? 1 and 8. Does everybody agree? Angle 1 and angle 8. Okay. Now, Demondre's got that conjecture ready to go. Conjecture. We think alternate what?
Alternate exterior angles.
Exterior angles are congruent. Everybody agree? Okay, so we could say, for instance, angle 2 is congruent to angle 7. Great conjecture. We think so it must be. You showed it. I don't even have to go back and show it. We already showed that one. It's great. All right, everybody good? All right, Samantha says something about corresponding angles. So let's go back and look at our picture. Corresponding angles. I told y'all there are a lot of C words in this class. It's crazy. Corresponding angles. All right. Corresponding angles are 2 angles that are basically in the same position on the parallel lines and the transversal, okay? So for instance, when I look at my picture here, I see angle 1 up here, and I would, when I call his position, I say, he's on top of line L, and he's on the left side of line P. So he's kind of like the top left, or exterior and on the left side, okay? So whenever I think about that as a position on top of and to the left of, which guide is in the same position on line M? 5. He's on top of line M and he's to the left of P. Okay, so they hold the same position. So they're considered corresponding. This angle on line L corresponds with this angle on line M. They're in the same spot. So for instance, angle 4, what does that one correspond with? Yes, 8. Because it's below line L, but it's on the right-hand side of the transversal. So below line M on the right-hand side of the transversal. They're in the same position. Different lines, but same position. That make sense? Angles that hold the same position. On a set of parallel lines. Are corresponding. The check box is in the way. Okay. Angles that hold the same position on a set of parallel lines are corresponding. Okay, so Miss Samantha said, aren't angles 2 and 6 corresponding angles? That was her question to us. So look at them. 2, he's on the top and he's on the right. 6, also on the top and on the right. So she's absolutely correct. So Miss Samantha, what would you like to say about corresponding angles? Do you have a conjecture? She's thinking, or she's typing maybe. I put her on the spot. She's like, I don't know. Don't do that to me, Dr. Webster. Okay, so let's just make sure she'll catch up, I'm sure. So let's look at it. We've got a bunch of stuff going on here. For instance, 2 is congruent to 3. How do I know that?
I think you said something.
They're vertical, right? They're opposite there, vertical. And 3 is congruent to 6. How do I know that?
Opposite interiors.
Alternate interior, exactly. So those are congruent. And Samantha just said they're the same angle along the transversal. Absolutely. So if I've got 2 to 3 and 3 to 6 and all of those are congruent, what do we think about 2 and 6? They're also congruent. Okay, so that's my conjecture. That corresponding conjecture. I love conjectures. Those are great. Conjecture. Corresponding angles are congruent. So in this case, I'm going to use Samantha's example. Angle 2 should be congruent to angle 6. And by the way, what we just did when we stepped through 2 to 3, 3 to 6, that's a little mini proof for the new high school people. So they're not bad. They're just mini proofs. It's okay. All right. So angle 2 is congruent to angle 6. Let's see it. Here's my patty paper. Can we see it? I just need to slide, right? Okay, so I just slide this guy up. We need to have already cut it, which we did earlier, so. And there it is, 2 right on top of 6. Absolutely, they have the same measure. Okay. So when I have a set of parallel lines like this that makes up 8 angles, I've mentioned it a couple of times now, you will almost always get 2, well, for a parallel lines, you will get 2 sets of angles. And for us, we've got these obtuse ones, 1 to 4, 4 to 5, 5 to 8. Okay, and then we've got these acute ones, 2 to 3, 3 to 6, 6 to 7. So they're either, in our case, obtuse or acute. Now, I say almost always because there is that weird situation. If I made the transversal be perpendicular, okay, what would happen? Everything's 90 degrees. So it's almost always we have two different sets of angles, some obtuse, some acute. But if I happen to make it perpendicular, of course, everything's 90 degrees. They're all congruent. So that's the weird case. It's a right angle theorem. It's out there somewhere. Y'all will prove it at some point. It'll be great. All right. That good? I think I'm caught up on my chat comments. Okay, cool. All right. Excellent. Corresponding, alternate interior, alternate exterior. Let's do some problems. Are y'all ready? I have 6 or 7 minutes. Everybody's good with our conjectures and our definitions? That's a lot. We're doing a lot of words today. We're doing a lot of words today. You ready for an example? Sure, I got all my vocabulary words in. Give me just a second. Yeah, I think that's it. Okay, so we need to stick it all together. There's something called a parallel line conjecture. See? And what it says is, if I have 2 parallel lines that are cut by a transversal, so you notice that all of these problems that we've had have always started the same. I actually use the same picture so we draw it, but they all start with like this. If you have 2 parallel lines with a transversal, cut by a transversal is what it should say, but going through them, I'll say same thing. If you have 2 parallel lines with a transversal going through them, or cut by a transversal is what I should have said, then three things are automatically congruent. Blank, blank, and blank are all congruent. Okay, now these are the situations we just had, so y'all don't let me down. We can do this. So what is specific to the fact that we had a parallel line, set of parallel lines cut by a transversal? Which 3 pairs of angles? So vertical angles can happen just because you have intersecting lines. They don't have to be the parallel. Now they're in there, and we absolutely will use them, but they don't have to be tied to the parallel line with the transversal. Okay, so alternate interior. That's one set that will definitely be congruent.
Alternate exterior.
Alternate exterior.
Corresponding angle.
Oh, good, Alexis. And corresponding angles. Absolutely. Absolutely. Those 3 sets. Okay, so you will have pairs of alternate interior, pairs of alternate exterior, and pairs of corresponding angles. And all 3 of those, if you know you have a parallel line to begin with, set of parallel lines to begin with, and that transversal, all 3 of those have to be congruent. That's the conjecture. We'll prove it later. For now, we're just going to say it's a conjecture. So here we go. I'm going to give you a picture. I'm going to give you just a couple of minutes, and we can do it, guys. Y'all are going to solve it. Here's your problem. Set of parallel lines. I'm gonna cut this transversal the other direction, just so that for sure we'll know it's a different picture from the one we've been doing. Okay. Then I'm gonna put this transversal in there. So 7, 8, 9, 10, 11, and 12. I'm going to add that lovely notation right there. What does that symbol mean again? Okay, these are perpendicular, right angle. Okay. And I'm going to say angle 1 is 30 degrees. The measurement of angle 1 equals 30 degrees. That's the way we'll write that. So the little m means measurement, the measurement of angle 1. And with that information, you should be able to solve the whole shebang.
Just find angle on all of them.
Find a measurement for each of those angles using the information we already know. Using your alternate interior and vertical. Give me just a minute. Sorry, a little time. Oh man, we lost Matt. I still don't have a Maria in here, do I? Oh, I do have Maria. I'm sorry. Oh. I apologize. Mary is in Mesquite. She's here. She's here. Jessica? Oh, Summer J. Okay. I'll get you. What's that J? I'm weird, I know. Summer L, I've got. So we don't have Amberly. Ashley. Is 6 and 7 supposed to be cut or, sorry, give me a second. 6 and 7 is supposed to be cut or there be a 13 and 14. Oh, there would be, like up here would be 13 and here would be 14. I just didn't give them. So 6 is the original angle here before I cut through. 7 was the original angle. So yes, you would be able to cut those into smaller ones, but I don't need that, right? So what do we think?
You want the simplified version or you want every angle? 'Cause I know, well, I feel angles 1, 4, 5, and 8 are all congruent to 30 degrees.
All right.
And then 2, 3, 6, and 7 are congruent as well.
All right. 2. And do we have a measure? Oh, not there.
Yeah.
Do we have a measurement for 2, 3, 6, and 7?
150.
Didn't 7 include the bit you marked out, though?
50 degrees. No, it doesn't. Oh,
Yeah.
Oh, yes, it does.
Congruent part?
Yes, it does. Sorry. I'm confusing myself when I do that. Hey, what do we have? Mary says 1, 4, 5, 8 is 30. 2, 3, 6, 7, 150. That's what we say too. So the only thing that we don't have, and I didn't mark it out, 9, 10, 11, and 12 are all 90. So if this guy is 30, I didn't mark it for you, so you didn't have to do it. But what would this guy right here be? Say he's angle 13, like Mary suggested. He would have to be how big?
60.
60 degrees. Does everybody agree? Because there's that little thing about a triangle adding up to 180 degrees.
60, 39.
Yeah, and then you could measure that out to 90 degrees there, which we know it is because it's also perpendicular, right? So good job. Absolutely. And those should all add up, right? So when we do this, for instance, angle, whatever this is, 13, plus angle 14, plus angle 8, better add up to 180 degrees still because they're a straight line, right? So all of our little rules that we have going on still have to meet, even if we have alternate interior and all that. Okay? Great job. I held you late. I'm sorry. Not according to my watch. My watch is wrong time. I don't know. Everybody have a lovely weekend. Do you have 1.1 that and 1.2 that handout due a week from today? Oh, and an email due by tomorrow, right? So don't forget my email. Thank you all. If you have questions, hang around. If that doesn't make perfect sense, I'll be glad to fill it in. Okay. Question for me? Yes, sir.
Yes.
No, I'm not the math head. I'm sorry. I run a lot of our programs. I'm gonna stop the recording now. If you're listening, have fun.